will be using RTAS, a real-time operating system here. Fine. So these are the main reasons why we are going for a real-time operating system. Okay. Now I can give an example. Okay, I can give an example for the real-time operating system. Okay, you can. I hope everyone have traveled in car. Okay, so in cars. Okay, in cars. Fine. You can see this is the difference between your general purpose operating system and your real-time operating system. Okay, so high priority tasks can be preempted. Okay, see it as most of the programs are running at the background. Fine, and the real-time task. Okay, real-time operating system. Okay, so always it will execute the higher task first. Okay, direct control on the task, and it is a standalone system. Okay, it's a standalone system. You don't need to have a keyboard or mouse to interact. Okay, so once the code is dumped, automatically it will perform the action by its own. Fine. So these are the difference between GPOS and then an RTAS. Okay, fine. So now these are the elements of real-time processing. As I said, see, low jitter. Okay, fine, and low latency. Okay, latency is the time taken to give the taken to give the response for a given amount of time. Okay, and then how long does your processor takes to respond to an event. Okay, fine, and then guaranteed processor accesses. Okay, fine. So these are the reasons. Okay, we'll go for the real-time operating system. Okay, fine. So now, okay, so in order to build anything, okay, using a real-time operating system, NI has a hardware-based, okay, NI has both software platform as well as hardware platform, and NI is providing, okay, various hardwares, okay, NI is providing various hardwares in order to perform, okay, or in order to build or in order to test a real-time system, okay, real-time system. So in order to build a real-time system with the help of NI software and hardware, okay. So as I said, right, we have different types of hardware platform and software platform available. So we call this, okay, a real-time, okay, the hardwares whatever we use to build a real-time operating system or a standalone system, which will comes under a family of hardware called Rio family hardware. Okay, so that's why the beginning of the session itself we have just given a title called NI Rio platform. Okay, NI Rio platform. Rio corresponds to reconfigurable input and output. Okay, reconfigurable input and output, and we'll give a justification why they have given a name as Rio. Okay, why we have given a name as Rio. Okay, fine. And now, so if you see, right, so this is the Rio architecture. I'll come back to the Rio architecture later. So this is the hardware, okay, which is rugged, okay, which is rugged, which is used to build a real-time system. Okay, real-time system. Fine. So if you see, the name of the hardware is called NIC Rio. We call that actually compact Rio. Okay, compact Rio. Rio stands for reconfigurable input output. Okay, under we have different families of hardware. We have DAC family hardware, we have Rio family hardware. Okay, so under this Rio family hardware, the hardware name is called C Rio. Okay, it is compact Rio, which has an inbuilt processor and it has an inbuilt FPGA. Okay, it has both processor and it has an FPGA inbuilt in it. Okay, so why this hardware has got a name called reconfigurable input and output? It's because of these hardwares has inbuilt FPGA. Okay, so FPGA is what? Reprogrammable. Okay, it is reprogrammable field programmable gate array. Field programmable gate array. Fine. So it is reprogrammable. Okay, fine. That's why it has got a name called reconfigurable input and output. Fine. So this NI Rio hardware has both. It has embedded processor and it has FPGA, okay, which is inbuilt inside the hardware. Okay, so whenever you want to do any standalone system, okay, standalone system, or if you want to build any real-time operating, okay, real-time applications, okay, you can make use of these Rio hardwares. These are the hardwares which are existing, okay, and it is used in lot of industries in order to perform a real-time application, to develop a real-time application, or not for testing purpose, for product development, or in order to make a system to be automated. Okay, in order to make a system to be automated, okay, so they will be using these hardwares for, okay, so they will be using these Rio hardwares for in order to build a real-time system. Okay, fine. And then we have one more hardware, and this is how the hardware looks. Okay, it has, you can see here, so you can see there are some small boxes. These are all we call as actually IO modules, okay, input output modules. It may be an analog input, analog output, digital input, digital output, okay. Modules will be there with respect to the requirement. We have different C series module, okay, so which will be connected to the chassis, okay, which will be connected to the chassis. The chassis is nothing but, okay, which has the back plane. You can see I have an FPGA board, you can see here. So this is a place where we'll be having your FPGA, all your pinouts, okay, all the pinouts are directly, yes, someone is trying to talk. Okay, all these pinouts are directly connected to the backplane of your chassis. The backplane only will be having your FPGA. Okay, so all the inputs, okay, will be outputs will be directly connected through the FPGA. And this is a type of hardware. So we call this actually compact RIO. Okay, compact RIO. So one will be integrated. Okay, where your chassis and your FPGA will be integrated. And this is actually removable. You can just remove your chassis separately, and then you can just remove the controller separately. Okay, fine. So this is integrated, and it is plug and play. Okay, plug and play. And these are the C series module. Actually, we call this actually a chassis. In all the chassis only, you can see the next image. Each and every, okay, modules will be inserted. Okay, and you can see there is one more hardware called PXI, peripheral extension interface. Okay, fine. So this is PXI. Okay, so this is a separate computer. Okay, where it has an, okay, it is a separate computer. If you want to work with this hardware, okay, if you want to work with this PXI hardware, okay, this has inbuilt processor, it has a memory, okay, it has RAM, ROM, memory, everything is inbuilt. Simple thing is what you need, if you have a desktop and a mouse, okay, only if you have a desktop, and then if you have a mouse, okay, you can just directly connect it, and you can program in the PXI itself. Okay, you can do the program in the PXI itself. Okay, no need of external CPU. Okay, no need of external CPU. Directly connect your mouse, keyboard, and then your desktop screen. Okay, desktop. Okay, you can develop the code inside the PXI hardware itself, because it is a computer. Actually, if you see here, this is what we call as a controller. Okay, it is a computer. Okay, where you will be having the RAM, ROM, okay, memory, hard disk, everything will be available here. Fine. It has a capability to store the information also. We call this all as IO modules. Okay, we call it actually all as IO modules. We call this is also we call as racks. Okay, and these are all the input output modules. Okay, so which are used for to various applications. Okay, fine. This is called as PXI. We have one more hardware called Flex Rio. We have Robo Rio. We have SB Rio. There are different types of Rio family hardwares are available. So in that, the Rio is a rugged, okay, rugged system. Fine. So and then the next one is going. This is the higher end version. Okay, more than Rio. Okay, it's called PXI. Okay, and then, okay, we are going to discuss about this Rio based platform hardware only for today's session, and we'll see how it is used. Okay, how it is used to build a real time system. Okay, fine. So now I'm just going to show a small video. Okay, which will show, okay, how fast, okay, which will show how fast the NI, okay, real time hardware works in order to perform a task or in order to perform an application. Okay, you can just look at this video.
Now, one of the primary uses for PACs is in machine automation. And our newest platform, PAC platform, Compact Rio, is ideally suited for these type of applications. So Kyle and Jonathan are going to show us how we're using Compact Rio and our compact vision systems to do high-speed machine automation. Thanks, Tim. An important feature of NI programmable automation controllers, or PACs, is the ability to reconfigure and customize onboard FPGAs with LabVIEW FPGA. This feature is particularly important when automating high-speed machines that require fast and reliable control. In this demonstration, we've taken the Compact Vision System and Compact Rio and built a machine that can sort different size ball bearings on the fly. Now guys, when Kyle says on the fly, he means literally on the fly. The machine we have here is loaded with hundreds of different ball bearings, the differ in size by just a 1/16 of an inch. Each ball bearing will travel down a ramp before it drops to the air. As it falls, the compact vision system, acquiring images at 100 images per second, will measure the size of each ball bearing to determine whether it is 1/2 inch, 9/16, or 5/8 of an inch in diameter. The compact vision system then communicates that result to compact Rio, which is controlling a high-precision chromatics rotary stage. As the bearing is still falling through the air, the rotary stage will quickly move to the exact position necessary to deflect the bearing into the correct bin. You want to see it work, Tim? I think I do. All right. There we go. All right. I see the compact Rio system. Yeah. I see the compact vision system, but where are the motion controllers? That's a great question, Tim. So we took LabVIEW FPGA and NI soft motion and reconfigured the FPGAs on both the compact vision system and compact Rio so they both become motion controllers. So the FPGA on the compact vision system is controlling the motor that's dispensing these ball bearings down the ramp. And the FPGA on compact Rio has been reconfigured to control this rotary stage that's powered by a brushless servo motor. With NI soft motion, we can turn any NI PAC into a motion controller. So really, Tim, we don't need specialized motion control hardware for this application. We just need NI PACs. Why don't we test our two motion controllers out a bit by speeding things up? You guys up for it? Nice. Now, how fast is your machine control going there? Well, as you can see on the screen, guys, we're sorting about 3 bearings a second, but I gotta be honest with you, Tim, this isn't the work of Kyle and I. This entire sorting machine was built by a team of engineering students from Texas A&M University. They learned to program with LabVIEW real-time.
Okay, so you have just seen about a small video. Okay, so with that, you people have just seen how we can build. Okay. Okay, so how we can build an real-time system. Okay, a real-time system. So in that video, you can see they have different ball bearings. Okay, of 3 different sizes. Okay, 1.5 inch and 9/16, and some other one more dimension. Okay, so all these ball bearings are kept in a small storage. Okay, so when the ball bearing are in fly, okay, on the fly, your system will automatically capture the image. Okay, to grab the image of the ball bearing. Okay, so that vision inspections, the vision system has a capability to get 100 images per second. Okay, so on the fly it will just grab an image. Okay, within 10 milliseconds the image will get processed. Okay, and based upon the dimension they have a parametrics. Okay, there is servo which will be controlled with the help of compact Rio. So that parametrics will move. Okay, based on the movement, those ball bearings, okay, those ball bearings will be just automatically placed in the 3 different storage. Each and one is going to store for one dimension. Okay, so this is how fast. Okay, this is a small example or a real-time demo which I have shown. Okay, which is used for building a real-time. Okay, it is used for ball bearing sorting. Okay, we can't imagine. Okay, so during the fly it takes around a fraction of second. It is grabbing the image, it acquires, it processes the image, it finds the dimension, and based on the dimension it is going to give a command to the parametrics, and then when it falls it directly stores and it falls on the respective place, okay, to store the ball bearings. Okay, see, this is how, okay, how fast your system is working. Okay, so this is a small example for your real-time application which they have built with the help of this compact Rio system. Okay, fine. So today, for today's now, okay, in this session and then in the next session, so we are going to work. Okay, we are going to work with this Rio based hardwares, okay, right? And then I'm going to just show a demo how we can build a real-time system by using this Rio hardware. Okay, how we can build a real-time system through using this Rio hardware, okay, and then how we can build a standalone system. That is the most advantage. How I can build a standalone system by using this Rio platform hardware, okay. And next thing is, as I said, right, it has embedded processor as well as FPGA, okay. So you cannot do any process at a higher faster rate than your processor clock, okay. So if you want to perform any task higher than the processor, okay, given processor clock, it is not possible, okay. Then you can just go for FPGA, where it can do any task at a rate of, in terms of nanoseconds, okay, not micro millisecond. In terms of nanosecond, you can perform the applications, okay, fine. So we'll be seeing all these things in the today's session, okay, upcoming session, fine. So now, as I said, right, you have different hardwares. As B Rio, we have C Rios, okay. Now we are going to work with the hardware called NI MyRio, okay. We are going to work with the hardware called NI MyRio. This is also comes under a Rio family hardware, okay. It has an inbuilt processor, it has an inbuilt FPGA, okay. It has an inbuilt FPGA inside, where you can create any real-time applications, okay, where you can create any real-time applications, fine. So now, to work with this NIRIO hardware, okay, it is like a smaller version of a compact Rio or PXA system, okay. This is this when you have this CRIO or when you have the PXI, okay, you can do all the industrial based applications, okay, right? So whenever you want to do any small projects, okay, you no need to rely on those CRIOs and PXI, okay. So when you have more number of IOs and if you want to perform any task at very high speed, then you can go for those two hardwares, okay. So this Myrio hardware is called like a miniature version, okay, a miniature version of those C compact POs, and then the PXI is where it has only less number of IOs, okay, less number of IOs here, okay, and the clock will be varied, okay. This is also having an inbuilt FPGA, and then it has a processor, okay, fine. So we are going to discuss about this. We are going to develop a real-time application, okay, today by using this Myrio hardware only, okay, fine, right? And we'll be showing how you can do the programming, okay, how you can do the programming using this Myrio hardware. Next part we'll be learning how I can dump the code using this Myrio, okay, and how this differs from MyDAC, okay, because we know that the MyDAC hardware doesn't have memory. It has only the signal conditioning components like amplifiers, filtering, and then it can convert. It has an ADC, DAC. It has buffers. Okay, it has a buffer. So apart from that, we don't have any processor or memory, RAM or ROM in order to dump the code or in order to log the information. Okay, so you know that when the DAC hardware gets power through the USB cable only, so it is transferring the data through USB. At the same time, it is getting the power also through USB. At any instant, if you remove the USB connection, automatically the connection will be lost between your MyDAC hardware and your application software LabVIEW. So you cannot transfer the data. Okay, you cannot transfer the data. Fine. This means always it should be connected to the computer. Okay, fine. So that type of that type of systems cannot be used whenever you want to perform a critical based application. Okay, critical based application. Simple example. Okay, you can just I hope everyone have come across this example. So we have actually airbags. Okay, we have airbags which is present, okay, which is present in the cars, okay. What is the use of airbags? In order to safeguard the passengers, okay, who is traveling in the respective cars here, okay, fine. So when, okay, think that a car is moving, okay, car is moving at some 30 km per hour speed or 20 km, 40 km hour speed, okay. If it hits an obstacle, okay, if it hits an obstacle or if it hits a barrier, okay, or a tree, okay, at a very less speed, okay, you know that the airbags will not come out, okay, the airbags will not come out from the car, okay. So whenever a car is moving at a high speed like 100 km per hour or 120 km per hour, okay, immediately if it hits the barrier, okay, automatically the airbag will come out and then it will safeguard the passenger, okay. This is what happening inside the car, okay, fine. But it met an accident, okay, fine. So the airbags will come out and it will safeguard the passengers, correct, right? Now you can just consider that if you're going to test the airbags, okay, if you're going to test the airbags, okay, if you're doing this, okay, if you're doing same thing with your general purpose operating system, okay, it is like a prioritized task. It has high priority. Whenever it hits, okay, immediately it has to send the airbag out in order to safeguard. Okay, if you use a normal operating system, if you use a normal operating system, okay, because we cannot prioritize a task, right? Like if it hits, okay, it takes less second, okay, it takes a more amount of seconds to process, okay, and in order to make the airbag to come out, so all the passengers inside the car will get injured, okay. At the same time, when we go for real-time operating system, that only task which is given to the operating system is what, okay, auto system, if it hits for the particular threshold, if without any delay the airbag should come out to safeguard the passenger, okay. So in these cases and all, okay, in these cases and all, you can go for this auto-spaced system, okay, auto-spaced system here, fine. So today we'll be working on this IDEO hardware, okay. So this hardware is called NI-MyRIO. RIO stands for reconfigurable input and output, okay. Why all these hardware has got a name called RIO? Because it has an FPGA inbuilt. It is reprogrammable, okay. It is reprogrammable. That's why all these hardware has got a name called RIO. Under that we have compact RIO. Compact RIO means, okay, so this is what we call as actually CRIO. So where you will be having a chassis, okay, where you can just plug and play, okay, inside the respective modules. Okay, modules are nothing but IO modules. Either it may be a digital input module, digital output module. Okay, fine. Or some will be on protocol based. Okay, fine. A CAN module. If you are going to read and write the data through CAN protocol, okay, it will support. You have separate CAN module available here for analog in, analog out. Okay. At the same time, if you are going to measure any information from a strain gauge, RTD, or thermocouple, okay, for all those things, we will be having different modules are available, okay. So all these modules will be coming with the signal conditioning, okay, inbuilt signal conditioning options, okay. I know you people, I know that you people already come across a word called signal conditioning, okay, fine. Because directly we will not give any signal to the input and output nodes of the processor or FPGA. So whenever we get any information from a sensor, that will get it will get conditioned first, okay. Once the signal get conditioned, and then only we will be sending the information to the respective hardware here, okay, fine. So all these will have the inbuilt signal conditioning parameters available, okay, fine. And the same time, if for it is applicable for this PXI also, okay. So we'll be calling this actually cards, okay, express cards, fine. So IO cards, fine. So only difference is what something will be in terms of BNC, something will have screw terminals, okay. So that as these are the difference, okay. Apart from that, okay, all the modules are going to read and write the information here, okay, right. So this is RIO stands for reconfigurable input output, right? So this is used, okay. You can use it for a research work, or you can just make your, if the hardware is available, okay. If the hardware is available, you can just make your students and you people can try to develop and deploy a real-time application using these hardwares, okay. I think someone have any question? I can hear the voice. Any question? Okay, no questions. Okay, so now, okay, so we'll be working on this hardware only. Okay, so this RIO comes under embedded platform. It has an inbuilt FPGA. Okay, right. This MyRIO hardware. This MyRIO hardware has analog input pins. Okay, it has analog output pin. You have digital input and output pins. Okay, you have audio pins available, okay. And then, right, so this hardware, okay, this hardware has a capability, okay, this hardware has a capability to read and write the information, okay, through USB, okay, USB. And then it has an onboard FPGA, okay. It has a capability to generate a Wi-Fi signal, same like Elvis 3, okay. It can generate a Wi-Fi signal, okay. The range is up to 150 meter. For example, if I have a hardware, if it is connected, okay, if I connected my system, okay, with through the onboard Wi-Fi of my RIO. So without using the USB wires, okay, for the data transmission, I can read and write the information. I can deploy, okay, I can do everything through wireless mode, okay, fine. So, and these are the options available for this my RIO hardware, okay. This is how your MyRio hardware look? It has Xilinx Zinc 7010, okay, where your embedded processor and FPGA are inbuilt, okay. So when you see this MyRio hardware, okay, so it looks like a small box, right? Okay, this hardware has some onboard LEDs, okay. It has onboard LED. You can see in the slide I have mentioned as user defined LED, so which is used for indication purpose, okay. If you want to, you want to performing something, if you want to make some indication, you can make use of the LEDs, okay. At the same time, if you see, this device has power LED, this device has status LED, and this device has actually Wi-Fi LED, okay. It has some user LEDs here, and then we have push button and Wi-Fi button, okay. So these are the onboard devices, okay. These are the onboard devices available. Along with that, we have an onboard accelerometer, okay. Along with that, you have an onboard accelerometer which is used for tilt, okay, which is used to measure the acceleration, tilt, and okay, tilt purpose. You can make use of this onboard accelerometer, okay. So if you see this MyRio hardware, this MyRio hardware has an USB port, okay. So the main use of this USB port is, okay, for example, if you are doing some a real-time application, you want to store the data in a pen drive, okay, you can just directly insert a pen drive in the USB port, you can just log the data. Second thing, okay, if you are going to use a back camera, okay, if you are going to use a USB based camera, okay, you can just connect it to the respective USB port. You can just grab or acquire the image, and you can see here there is an option called device, okay, connection to PC. As I said, right, when you use this MyRio hardware, you can have the data transfer between your system and the hardware through USB, or else you can go for onboard Wi-Fi, or else you can make your MyRio hardware to connect with the existing Wi-Fi signal available, and you can have the data transmission and reception, okay. Anyway, this hardware needs power because it's an electronic hardware. So whenever you provide a power, then automatically it will start to work. So you have a power option here, power port is available, and then you have a reset button, okay. So these are the pins, okay, available here. And then this MyRio hardware, okay, so this MyRio hardware actually, it has three ports, okay. It has three ports are nothing but, okay, so it has pin outs, okay. It has three, we call as one, we call as actually MSP connector, okay. This one we call as MSP connector. This will be exactly same like MyDAC hardware, okay. This will be exactly same like your MyDAC hardware, fine. So in MyDAC you will be having analog input, analog output, or you'll have audio in, audio out. You have digital input and digital output, right? Okay, the same way. So here also we have audio in, audio out, okay, and then we have digital in, DIO pins. We have analog input output pins here, okay, and we have two more connectors, okay. So right, so you can see here in this MSP. Fine. So 1 minute. I hope you people can see my screen. Okay. So I think the screen is visible now. Okay. You can see the hardware. Okay. This is what we called as NI MyRio. I think it is visible to everyone. You can see my screen. Okay. So this is how the hardware looks. Okay. And if you want to check this hardware, you can see it has three ports, okay. Whatever we have just seen in the slide, fine. You can see, let me just remove the USB. Okay, see, it has actually three ports. You have USB, you have device, you have power, and then you have reset option, okay, at the same time. So as we have seen in the slide, it has a port called MSP, okay. It has a port called MSP port, okay. This port will be exactly same like your MyDAC, okay. I think you can see here, okay. It has audio input, you have analog out, analog in, you have digital in and digital output, okay. And as I said, right, you can see it has LED. See, it has power LED, it has status LED. Okay, so power is just to define whether it is powered or not. Status, okay, so when it is a computer, as I said, it is a computer, right? Whenever it is booting or whenever you are going to install a software, that status will be updated with the help of LED. Even if there is any issue or if there is any error in the while compiling or installing, right, that will be defined in the status LED. You have an option, see, Wi-Fi LED. which will tell us whether the system is connected through onboard Wi-Fi or it is connected through existing Wi-Fi connection. And you can see here I have LED 0, 1, 2, 3. Okay, so we have 4 user LEDs. Okay, so which is used for user. Okay, fine. At the same time, you can see here I have buttons. Okay, I have buttons here, right? You can see. So one is to reset your Wi-Fi, and another one is button. Okay, it is just like a push button. Okay, and this one we called as MXP C port. Okay, sorry, this two ports are called as MXP port. Okay, you have A port and B port. So MyRio has totally 3 ports. Okay, A port, B port, C port. A and B are called as MXP, MyRio extension port. Okay, so right, and MSP is called mini system port. Okay, and totally MyRio hardware has 3 ports here. So this is how your hardware looks. Okay, and if you see at the back end, you will be having an onboard accelerometer. Yeah, I think now you can see. So we have onboard accelerometer. Fine. So now what I'm going to do is I'm going to provide power to my device. Okay. You can just see. See, once I provide power, okay, once I provide power, immediately my power LED gets turned on and the status LED is glowing in orange color, which means that your system is on and it is okay. How you, whenever you just turn on your laptop, your OS will get booted, right? The same way. Okay, so it will get booted up, fine. And once it is booted properly, that orange color LED will get disappeared. Okay, you can see here, fine. You can just see now it is powered. Okay, so now I'm going to read. Okay, I'm going to read and write the data. I'm going to read and write the data through USB. So I'm going to connect the USB cable. Okay, so that we can have data transmission between the system. Later part I'll say how to make a standalone system. Okay, fine. Yes. Fine. So now once my system, okay, see, these are the pinouts. Okay, as I explained, right? So these are the pinouts. See, once your MyRio hardware is connected, you will be getting the screen called NI USB monitor. Okay, so this will display the serial number of the MyRio and the IP address. Okay, now see MSP connector. MSP connector. I have the pinouts. Okay, you can see here they're just given a number. So I have 15 plus or minus 15 volt, and then I have analog ground, analog output, analog in. Okay, analog output 0, AO 0 and AO 1, 2 channels, and then you have analog ground, and then you will be having analog input AI 0 plus 0 minus 1 plus 1 minus. Okay, these are configured in differential configuration. Okay, and then you will be having digital input and output. And you can see here this hardware has the capability to perform counter operation. It has an encoder. Okay, it has an inbuilt encoder. As a encoder purpose, you can make use of these pins. And then if you have, you can see it can generate 2 PWM signals. Okay, through C port. Okay, DIO3 third pin, and then through DIO7. I can make use of these pins either as digital in or digital out. Okay, or else you can just make use of this to generate or to acquire the pulse information, PW information. Fine. And next one you can see here we have called as, we have 2 more ports like A port and B port. Both are identical. Okay, so we call as actually MyRio extension port. Okay, so in MyRio extension port, okay, so I have how many pins totally? So 1 to 34, totally 34 pins are available. So in this, okay, you can see here the first pin is used to provide power. Okay, 5 volt, and then you can see here the first row will have odd numbers, and the second row will have even number pinouts. Okay, fine. So you can see here I have AI0, AI1, AI2, AI3, which means that I have 4 analog inputs. Okay, 4 analog inputs in one channel. Okay, one port. At the same time, if you see here, I have AO0, AO1. Okay, 2 analog outputs. If you see all together, you will be having 10 analog inputs. You will be having 6 analog outputs. Okay, and if you see digital input, It starts from DIO0. It starts from DIO0. It ends with DIO16, which means there are totally 16 DIO pins in one port. So A port 16 pin, B port 16 pin, and then 8 pin in C port. Okay, totally we have 40 digital input output lines in this MyRio hardware. Okay, at the same time, this hardware will support, okay, protocol based sensor. Okay, so we know that some of the hardwares will work with respect to some protocols. For example, we have CAN protocol. Okay, we have the serial communication protocols are like I2C, okay, right? So and then you have SPI protocols, serial peripheral interface. You have UART, okay. So whenever you have such type of sensors which works with respect to the protocol in order to have a data transfer, right? So this hardware will support for I2C protocol, SPI protocol, and then UART. Okay, you can see here I have something called as UART TX, UART RX, okay, in 14 and 10. So these two pins will support UART protocol, and if you see some pins they have mentioned as I2C, okay, I2C dot SDA and SCL. So this is used for I2C based protocol data transfer, okay. And then we have SPI. SPI corresponds to serial peripheral interface, okay. So where you can have SPI based protocol sensors can be connected to those pins in order to read the data, okay, or not to give this information, command information to the respective sensors, okay. So this is the advantage of using this Rio hardware, where it will support protocol based applications also. Fine. So these are the pinouts, okay, for this MyRio hardware. One thing, if you see the range, okay, and here also through MyRio hardware you can just read the voltage information through the analog pins, okay. The range, the voltage range which you can read is 0 to 5 volt, okay, for your MXP pin, okay, for your MXP port, A port and B port. When you look into the C port, you have an option to read and write the voltage from plus or minus 10 volt, okay, plus or minus 10 volt here, fine, right? So this is the pinout configurations. If you want to look into the data sheet also, you can just we'll look into the data sheets, fine, of the MyRio hardware later, okay. So this is just an introduction about this NI-RIO hardware. Next step is we are going to try to learn. Okay, next we are going to learn how we can develop. Okay, how we can develop a code and how we can deploy the code using your MyRio hardware. Okay, fine. So now let me know if you have any queries. Okay, so now I'm going to demonstrate. Okay, by using this RIO hardware. Fine. So if you have any queries, you can just ask me. Any queries? Any queries? No? Okay, fine. So we'll just move on to how we can develop a program. Okay, so this is the introduction to the hardware. Next step is we are going to learn how we can develop a small application using this NI-RIO based hardware. Okay, so I'm going to use a hardware called NI-MyRIO. So if you want to work with the hardware, okay, so in your system you should have installed LabVIEW software and the respective RIO drivers. Okay, the NI-MyRIO driver should be installed. Okay, so in the system, at the same time whatever the software we use in your system, because we know that MyRIO is also a separate computer which has a processor inbuilt inside, right? It has, okay, in the same way, so inside your MyRIO also, so we have to install, okay, we have to install the respective softwares, okay. So if there is a mismatch of software version, if there is a mismatch of software version between in your system and your MyRIO, so you cannot deploy the code, okay. So make sure that if in my system, if I have LabVIEW 2018, okay, and the respective MyRIO drivers in 2018 version, the same 2018 version LabVIEW software should be in kept inside and installed in the MyRIO hardware, then only you can just dump the code in the respective hardware. Fine. So now the first step, always whenever you just connect NI hardware, as I said, you have to just go for measurement and automation explorer. We call it as actually NI Max. Okay, we call it as actually NI Max in this. Okay, And as I said, it is a separate computer. It is a separate computer. This hardware will be detected under remote system. Okay, this hardware will be detected under remote system. Just expand the remote system. Expand the remote system. You will be getting. Okay, so it will search what are the hardwares available. Okay, and then see it is displaying NI MyRio. Okay, it is displaying NI MyRio. When I just click on the option, NI MyRio, fine. So this will display the Rio information. Okay, you have three tabs here. Okay, when you see in NI Max, you'll be having different tabs: system settings, network settings, and timing settings. If you see under the system settings, okay, you can see I have host. Okay, IP address is 172.22.11.2, which means it is connected through USB. Okay, and this is the hardware name, serial number, firmware, and you can see the operating system is Linux RT ARM v7. Okay, fine, and status is connected running. So which means there is no software issue because both the system are having same software. Okay, if you want to check what is the software installed, you just expand the MyRio. You have devices and interface, and then you will be having software. Okay, when I just expand the software here, it is showing MyRio 18.0, which means that the driver whatever I have installed, okay, right, all comes under same version. Even my system is also having 2018. Okay, so software issues will not be there. Okay, fine. So next step, if you want to test, okay, so I said once you install this, right, so if you see there is an option called network setting. Okay, so in this network settings only, we will be having an option to configure, okay, whether we want to do the data transmission, okay, whether we want to do the data transmission through wired mode, okay, or wireless mode. Okay, so under you can see wireless adapter WLAN 0. Okay, so in this, if you see wireless mode, it is disabled. We have two more options: connect to wireless network, and third one is create wireless network. Okay, so connect to wireless network means you can make your Rio to be connected to an existing internet network connection. Okay, and create wireless network means, so this, as I said, this hardware has an option to generate a Wi-Fi signal, right? So you can, if you select the create wireless network, so automatically this hardware is going to generate a Wi-Fi, and you can read and write the information. You can communicate through Wi-Fi option. Okay, so we'll be seeing all those things in the demo. Fine, how we can do the data transfer using wireless mode. Okay, so if you see here, once you connect the MyRio hardware, if all the software, everything is installed properly, if there is no mismatch of software version, right, you sure does do nothing here. There is an option called launch the IO monitor. Okay, launch the IO monitor, and then there is an option called launch the getting started window. Okay, if I just click on launch the getting started window, automatically they have, okay, it will start your MyRio hardware. Okay, it will start your MyRio hardware. See, found on MyRio hardware, just click on next. Okay, if I just click on next, if all the software connections, everything is proper, okay, automatically code will get opened. Okay, fine. So it is checking the NI software compatibility, whether everything is matching properly. Okay, fine. So once it checks, okay, and then it will display the information, okay, the respective screen, right? So you can develop, and one more, so whatever the things you have learned till now, okay, so you'll directly open LabVIEW, and then you'll just select file new VI. You'll start to develop the code. Okay, once you've started to work with this Rio based hardware, okay, fine, so you should not directly create a VI, because when you create a VI directly, that VI will be running in your system only. But whenever you want to do anything with Rio hardware, okay, any NI Rio based hardware, so first you need to create a project. Okay, you need to create a project. See, it is showing this is the Rio name. If I give next, okay, see, this is the VI, default VI, which will run whenever you just open this launch getting started wizard. Okay, as I said, right, this hardware has onboard onboard devices, right? LED, you have accelerometer, you have a button. Okay, fine. So just a minute, you can see it in the IP cam. You can see here, Okay. Yes. See here the two LEDs are on. Okay. If you see the two LEDs in the Rio hardware is on. When I just click on the buttons, okay. When I just click on the button, you can see here the both the LEDs. Okay. Both the LEDs are in off state. Okay. So now all four LEDs are turned off. Okay. When I just click on, see the first LED will get turned on. I think you can see in the screen. Okay. And if I just go with second one, I can just control the LED. Okay. Through my Rio. Okay, and you can see third one, fourth one. Okay, so now all the LEDs are on. If you want to turn off, you can make use of this. Okay, and if I do something with the, and you see, if I just shake the hardware, okay, you can see the accelerometer access parameters are changing. Okay, if you see, okay, if I do tilt, okay, you can see that it is automatically getting varied in x-axis, y-axis. Okay, fine. So tilt, right, and vibration, everything, right. If I tap, automatically it is measuring the vibration information, everything can be shown. And this hardware has a push button, right, it is available here. When I just click on the push button, okay, you can see the LED will get in the screen. Okay, in the VI, the button will, the status of the button will change. Okay, see, I'm pressing the button, we have to just see the status here, have to see the status here. Okay, see, it's on and off. Okay, I'm pressing a button, so it is on and off. Okay, fine. So this is how you can see the onboard LED working. It is just an example. Okay, so now we'll try to develop a program in order to work with this and, okay, work with the onboard devices. Okay, this is just an demo. Fine, and then I'm going to give next. Close. Okay, fine. So we have IO monitors also to see your input and output responses. Okay, first thing, okay, always first thing whenever you want to develop any program, okay, whenever you develop any program, you have to just open this LabVIEW. Okay, fine. Once your LabVIEW, okay, once your LabVIEW gets open, fine. See, there is an option called file. Okay, there are two ways to create projects. Okay, there are two ways to create a project. Keep it in mind whenever you're going to work with any Rio-based hardware platform. Okay, always you have to first create a project. After creating a project, we call as actually targets. The hardwares we use a word called targets. So this target should be added under your project. Okay, this target should be added under your project. And if you want to dump any code, okay, whenever you want to dump and deploy any code in your Rio hardware, so you have to develop all the VIs under the target only. Okay, under the target only. So what we can do is I can just go for file. Okay, see, I'll tell you how to first create a project. Now go to file, and then you can see there is an option called create project. Okay, there is an option called create project. So you can just go with the option create project, or else you can see there's an option called new. Okay, so when I just click on new, right, when I just click on new, you can see here a new screen has been displayed, a pop-up has been displayed here. So by default, which one is selected? Empty project. You can see by default which one is selected? Empty project. So when I just go with OK, okay, so when I just go with OK, so automatically a project will be created. Okay, so see, automatically a project will be created under this project. Okay, under this project, so I have what project untitled one. Okay, right, so it has not been saved a name, so it is showing as untitled one. I have my computer under my project. Okay, so whenever you try to create any VI under my computer, which means that that VI will be running inside your system only. Okay, but what is our goal? We have to write a code and then we need to dump it inside the respective NIRIO hardware. Okay, so in order to write and dump the code inside the NIRIO hardware, okay, so what you can do is you need to first add the target. Okay, we need to add the target under this project. So now only my computer is added. So when you just right click, okay, right click the project window, right, and then you can see there is an option called new. So in this, you have to select an option called target and devices. Okay, you can see there is an option called targets and devices. Just click on targets and devices. Okay, just click on targets and devices. Okay, so if you have already installed all the softwares and if the hardware everything is proper, okay, you just go with an option called existing target or devices, existing target and devices. Under this existing target or devices, okay, see, you can see there is an option called LabVIEW, Ethernet Rio, My Rio, okay, real time compact Rio, okay, real time compact vision system, okay, we have real time PXIs, we have SB Rio, Robo Rio, okay, all these are available. Fine, so you can just expand My Rio because I'm working on a hardware called NI so just expand NI so whatever the hardware, okay, whatever the hardware which is detected under this NI okay, you can just select that option. Fine, so NI you can select and then just click on OK. So once you just click on OK, so immediately this hardware, okay, this hardware will be added, okay, this hardware will be added under your project. See, this showing discovering screen devices and discovering chassis, okay, and yes, now you can look into the uh, project screen. Okay, before it was only my computer. When I just added the target, okay, when I just added the target under my computer, okay, you have NI okay, as I said, NI has both FPGA as well as processor. Okay, when I just, you can see here I have NI chassis, okay, and then I have FPGA target, okay, I have FPGA target, and then you have okay, one is processor and another one is FPGA, right? Both are available. Okay, this one is for processor, this is for FPGA target here. Fine, and next thing is, okay, so we'll just see how to work with the onboard devices in through RT, and then we'll move on to FPGA. Okay, so we'll first work with RT and then we can move with FPGA. So I'm going to just right click. Okay, if you want to develop any code, right click on NI okay, right click on the NI option. You can see there is an option called new. Okay, there is an option called new, and then you have to select VI. Okay, so new VI. When I just click on new and VI, you can see a new VA has been created. Okay, new VA has been created, and if you see at the bottom of the VI, okay, it is if you see at the top also, this VI is inside the project, okay, and it is inside the NI 1900. Okay, this VI is under NI it does not belong under my computer. Okay, because whenever you create any VI under my computer, that VI will keep on running inside your system only. You cannot read and write the data through the MyRio hardware. Okay, that's why I have just created. Okay, I have just created a VI in your, okay, under MyRio. Fine. So now expand. You can just go to the block diagram. Okay, so after this, when you just right click, whenever after once you create a VI, okay, when you just right click, you can see here, we know under block diagram, this is what we call as function palette. Okay, inside the function palette, okay, inside the function palette, so we have an option. Okay, we have an option called MyRio. Okay, we have an option called MyRio. So you know how to develop a program with MyDAC. So you'll go for measurement IOs, and then you'll go for NI and then you'll be developing the code. Okay, in the same way. So if you want to do any code with the MyRio RT, okay, MyRio RT, just open a new VA under RT, and then you can select MyRio, and you can see we have lot of options available. Okay, analog in, analog out, digital in, digital out. If you want access button, you can make use of button. If you want to access LED or onboard accelerometer, you can make use of this. See, as I said, this is going to support protocols, right? I2C, SPI, and UART. So all these options are available here. Okay, fine. This is high level programming. So if you want to develop any code, okay, if you want to develop any code with low level VI, there is an option called low level. You can make use of this. Okay, fine. So now I'm going to develop a code. Okay, just to make my to turn on and turn off my user LED through my system. Okay, through my system here. So before starting the code, if you have any queries, please let me know. Any doubts? Any doubts? Any queries? Okay, no reply. Okay, fine. I'll go with the VI. Fine. Simple. Okay, simple is if I'm going to press the button. Okay, if I'm going to press the button, then I want my LEDs to turn on and turn off. Okay, I want my LEDs to turn on and turn off, which means that okay. So when you press the button in the NI Rio hardware, we have an onboard button, right? If you press the button, automatically that true signal should be updated. Okay, updated to your LEDs. Okay, fine. So here all the inputs. Okay, here all the inputs, output pins. Okay, all the NI pins have been directly connected to the FPGA. Okay, they are currently FPGA input pinouts, which means there will not be any delay to transfer the signal. Okay, through FPGA, because as all the IOs are directly connected to the FPGA or without any wire, right? There will not be any delay also. Will not to get the data through wires, because all the pins are directly connected to all the IOs. Okay, all the IOs are directly connected to the FPGA pinouts. Okay. Now, whenever you're trying to develop, okay, whenever you're trying to develop any program under RT, your FPGA will not do anything. We call as actually scan mode. It will directly take all the data from FPGA and it will be directly given routed to the embedded processor. Okay, embedded processor, the controller. So the FPGA will not do any process. If you develop any code under FPGA, okay, then only the code will get processed by the FPGA hardware. Fine. So the first step, okay, let me take a button. So go to NI Rio. You can take button. Okay, once you select the button, you'll get the option here. You can just place it in the block diagram. Okay, so it'll show the button. Okay, you can just give okay. So the button is configured. Okay, so whenever you press the button, that will be that's going to give a high signal. Okay, button is nothing but it has only two possible value, true and false, or 1 or 0. That's why the value, the label value is displaying green in color. Fine. And then we know that in order to run a program in a continuous way, always we'll be using what? Loops. Okay. To run the program in a continuous way, I'll be using loop. And then we know that always we have to give a stop button. Okay. And next thing, in order to reduce the more amount of CPU usage, you can have the timing part. Okay. Wait ms create constant. Okay, let me give 100 millisecond delay. Fine. So now when I just press the button, I want to make my real-time onboard LED to turn on and turn off. Okay, to turn on and turn off. So for that we have to just call the LED option also. So right click on the block diagram, go to MIDO. You can select LED. Okay, when I select the LED, you'll get pop-up because we'll be having four LEDs. Right? We'll be having four LED. So LED 0, LED 1, 2, and 3. Okay, so let me use LED 0 and 3. Okay, 0 and 3. I've disabled all those things. Okay, fine. So and then I'm going to give okay. If you're going to give any name, that name will be displayed in the screen of your block diagram. Okay, fine. And then I'm going to give okay. Fine. So if you see here, I just connected a boolean. Okay, it's the button. Okay, which we are going to click, and then automatically when I just press the button, one LED should get turned on. Okay, I'm going to just make a small logic. Okay, whenever I press the button, I want one LED to be in on state and another LED to be in off state. Okay, when I'm going to be in, when I'm not going to press the button, I want one LED to be in on state and another LED to be in off state. Okay, so this is the logic we are going to do. So what I'm going to do is, so when I just press the button, I want one LED to be in on state, so that I can connect directly. Okay, next step, is what? So when I just want to make my LED to be in off state, whenever this is on, this is off. Okay, so I'm going to go to Boolean palette. I'm going to take a NOT gate. I'm going to connect it. So now I'm going to connect here. Okay, now there is no error here. And first thing, once you started to do the code under project, if you're going to do any VI under the review targets, right? So usually whenever we try to run any do any code in DAC, okay, using my DAC, or if you're going to do any small programs in LabVIEW, if you just click on the run button, immediately, okay, the program will start execute. Okay, fine. Here we are going to read and write the information, or going to read the command to your through Rio hardware. So we'll just write Rio hardware. Fine. So what we can do first, whenever you just click on run button, the code will get compiled and then it will be deployed inside the Rio hardware. Okay, it will get deployed inside the Rio hardware. Once it is deployed properly, if there is no error, okay, if there is no error, and the code will start to execute. Okay, code will start to execute. Fine. So now I'm going to just click on run button. You can see it will first ask you to save your project and then VI, and then it will deploy. Okay, it will go for deploy. So when I just click on run, okay, so if you see in the project window, your MyRio hardware is there. Okay, so I'll just minimize the FPGA option. See, the VI is mentioned as untitled one. If you look here, it is mentioned as untitled one, but it's inside the MyRio. It is not under your my computer. Okay, so now if I run this, first it will ask you to save the project. Okay, see, it is deploying. It's deploying. It will ask us to save the project. Just going to save the VI. Your hardware. Okay, so once your code is saved, okay, so automatically once the deployment gets over, it will close. Okay, and then your program will start to run. Okay, program will start to run according to the instruction. Okay, according to the code whatever we gave. If you're not going to press the button, one button will be in on state, another button will be in off state. Okay, if you press it, one will go to off state, another will go to on state. Okay, that's what we have just given. If you see that, okay, if you want to see that, you can see. Okay, so one is power LED. Okay, one is power LED, and another one is going to be LED 3. Okay, when I just press the button, see, LED 0 will be on and this LED 3 will be off state because I used what and not gate. When I remove, LED 0 will be in off state, LED 3 will be in on state. Okay, click. You can see when I remove, it will come back. Okay, so now your code has been dumped. You can ask a question, sir, after dumping the code also still you have connected the USB. Okay, still you have connected the USB, and now if you see, okay, if you see in this laptop side, I'm going to remove the USB connection. Okay, I'm going to remove the USB connection. Now the connection has been lost. Okay, now the connection has been lost between my code and the Rio code. Okay, see, it is showing warning connection to the target has been lost. I've just given OK, right? But if you see here, still, okay, my code is executing. Still, my code is executing even though if you have removed the connection. Okay, if you click, see, again my code is running. Okay, why? Because the code is now deployed inside your RT. Okay, code is deployed inside your RT and it starts to work. Okay, and it starts to work here. Fine. See, even though after removing the USB cable it works, but if you remove power, okay, if you remove power and if you provide power again, okay, we have to see whether the code is working. Remove the power. Okay, you can see here I removed the power here. Again I have given the power connection. See, the status LED is on, which means that it's getting booted up. Yes, it is booted, but now if you see, I press the button, the code will not run because the code is stored inside the RAM. Okay, it is non-volatile memory. Okay, fine. So automatic, right? So it is not stored in ROM, it is stored in RAM actually, fine. So the code has been automatically erased. Okay, you can ask a question, sir, if you once the code is deployed, okay, so if you want to build a standalone system, even though if a power goes and if power comes also, the code should run, but it is not running. Now we have not built any standalone system, we are just trying to deploy the code inside the Rio. Okay, once the power goes, automatically if you get power, okay, it will not, okay, the code will be erased, it will not be stored in the system. Okay, it will not run again. Okay, in order to, even though if the power goes and if power comes, if you want to make as a standalone system, so we have to do some additional settings. Okay, from options will be there, so with that only you can just create a real-time system. Okay, so this is how we can deploy. Okay, you can develop a code and we can dump inside the MyRio. See, now after connecting the USB again, it is showing USB monitor. Okay, there is no error here. Fine. So after the lunch break, right? So I'll be explaining. I'm going to show a demo how you can create a standalone system. Okay, how you can create a standalone system. At the same time, I'll be showing the data sheet of the MyRio hardware. Okay, in that we need to. Then I'll be explaining how we can develop the code in FPGA also. Okay, so FPGA, how when we deploy any code in FPGA, we'll see how it is going to work.
Excuse
Okay.
me, sir.
Yes, sir.
Sir, last 5 minutes more.
Okay, so it is last 5 minutes. Okay, now it's 12:57, I think so. If you have
Yeah.
any queries, you can just ask me. I'm ready to explain your doubts, because after this next session, we'll be
2 o'clock,
seeing.
sir.
It will be on 2 o'clock. Okay, so we are going to discuss how we can create a standalone system. Okay, still now we have not seen about building a standalone system. We're going to discuss how we are going to create a standalone application using this NI hardware. Please let me know if you have any queries, any doubts. No queries. After the lunch, I'll be explaining about how we can develop the code in FPGA, how it is going to deploy, and how the way we. Okay, sir, want some guidance to beginner, those who want to know about LabVIEW. Okay, no issues. Will help you out, ma'am. That's not a problem. So you can just, anyway, after the session gets over, I'll be just sharing my contact detail. So if you want to get any guidance regarding LabVIEW, you can just contact me. I'll help you out. Fine. So maybe if you want, I can just share my number. So this is my mobile number. You can just reach me. It's for all. Okay. If you have any queries, okay, regarding NI technology, you can just reach me at through the number. This is my WhatsApp number too. So and I'm just sharing my email ID also. Sorry, I'll just give my email ID one more time. Which is not. Yeah. So this is my email ID and my contact number. So if you have any queries regarding NI technology, you can reach me at any time, no issues. Or if I'm not responding to the call because I'll be in some client meetings and all, so that yes, okay, fine, we'll help you out, no issues. You can just reach me. I think someone has shared their email ID. Okay, fine. So I think Manjushri ma'am, you can just contact me after 1 o'clock itself. If you have any queries, I'll help you out. Any doubts? No doubts? Okay. Sir, if you want to have a break, we can just close the session now.
Yes, sir. Thank you, dear participants. We'll have 1 hour break, and exactly by 2 p.m. we'll start with the next session.
Okay.
Yeah. Thank you, sir.
Fine. Thank you, sir.
Yeah. Thank you.